Thank you for coming. I'd like to thank the Science Tech Club for having me here. I know you all come here seeking knowledge because they did not teach you this in college. I got this down to a T and it's free. So, welcome to my show called Gold and Diamonds. Thank you, Greg, that's fine. Normally, these shows I bring props. That is, for some reason, I just couldn't afford it this time. So, in lieu of that, and I don't have a gold bullion bar with me, so instead of that, we'll just do this whole show on the cheap. Instead of talking about gold, well, we'll talk about golden retrievers, golden roll, golden parachutes, gold double flower, and our golden years. And instead of gold bullion bars, we'll talk about beef bullion cubes, and the proverbial pot of gold at the end of every rainbow. Politicians always promise us near election times. And instead of diamonds, since I don't have the whole diamond in my pocket, we'll be talking about baseball diamonds, Arizona Diamondbacks, Diamond Head, Hawaii, Neil Diamond, Diamond Jubilees, and Lucy in the Sky with Diamonds. Who wrote this? Okay, with gold, what we're talking about is origins, chemistry, history, the mining of gold, uses and applications in our society and the world, and alloys mixed with gold. Once every 100,000 years or so, two neutron stars or super dense cores of dead suns collide. 4 billion years ago in our galaxy, there were such collisions of neutron stars. Neutron stars are about 10 miles in radius, and 1 teaspoon portion of this star weighs 1 billion tons. A huge quantity of heavy metals form from these massive collisions and titanic collisions. These collisions produced and ejected 10 moon masses of gold, platinum, metals, and some of that was delivered to Earth by meteors. The dust in our solar system then from the collision of these neutron stars came to Earth by large meteors during the heavy bombardment period. Meteor bombardments 4 billion years ago brought 20 billion tons of gold and other precious metals to Earth. The gold then sank into our Earth's crust, so your bling began as a bam. Our jewelry is colliding star matter. Even our blood contains 0.2 milligrams of gold. Basic facts about gold. The old Latin name for gold is aurum, or glowing dawn, where we get the Au chemical symbol from. Melting point 2,000 degrees Fahrenheit, boiling point 5,100 degrees. Atomic number 79. Hardness of 2.5 on the Mohs scale, same as your fingernail. A strong person can squeeze gold, pure gold, in their fingers. It's the only metal that is golden. It's one of the least reactive chemical elements and is non-toxic. It resists degradation by air, moisture, and most acidic conditions, meaning it doesn't rust or corrode. Gold has 79 electrons in 6 shells, closest in 2, 8, 18, 32, 18, 1, which exist at different energy levels. Gold doesn't bond with other elements such as oxygen because gold atoms like to stick together. It pulls in its electrons, which means it doesn't share with other elements. 1 gram of gold can be beaten into a sheet 1 square meter. That makes it malleable. 1 ounce of gold can be stretched out 5 miles long. That's why it's ductile. And 1 cubic foot of solid gold weighs 1,200 pounds. That's why it's heavy. The ancient Egyptians smelted gold 5,600 years ago, and the first gold coins were minted in the Near East around 600 BC. And they were an amalgam of gold mixed in with silver into it. The amalgam was called electrum. Between 1492 and 1600, 8 billion ounces of gold came from South America. In the 18th century alone, 48 million ounces of gold were mined in Colombia, which made Spain rich and a superpower. California gold rush was in 1849 and produced 137 million tons of gold, or $100 billion in today's money. The Alaska gold rush was 1896 and lasted 2 years. And as shown to the bar to the very left, right? Thank you. Most of the gold has been, 90% of the gold has been mined in the last 120 years. Most of that coming in the last 70 years. And a gold digger has its own sexist connotations. Gold was once used for the backing of paper currency, but this ended in the 1970s. And now 1/3 of all gold is held by governments, banks, and private individuals. The Canadian gold coin is purest at 99.9% pure. Our oceans contain 20 million tons of microscopic gold. 1 cubic mile of seawater contains 25 tons of gold, or 1 milligram in every ton of seawater. All gold ever mined equals 1/3 the Washington Monument, or 3 Olympic-sized swimming pools, which is what these buildings are in, or a cube 66 feet on each side, shown here. If you want to know what 100 tons of gold looks like, it's parked in front of this garage. So it's about 170,000 tons mined thus far. Veins of gold in the earth are the result of hot fluids like magma flowing through gold-bearing rock, picking up gold and concentrating it into fractures. And when streams cut through these deposits, then flakes and nuggets are found in these alluvial deposits. That's why people pan for gold in streams. There are still over 100,000 tons of gold to be mined in the earth. An interesting side note, the Vertibord crater in South Africa was struck by a meteor, which seeded the Witwatersrand Basin in South Africa with gold, which was once the largest producing area of gold. Actually, 2/3 of the world's gold was once mined in South Africa. But this changed this century. Now, shown in the bottom bar graph, China is the leading producer of gold with 450 tons. Australia, per year. Australia second, Russia third, and the United States just over 200 tons of gold per year. The largest gold mine is in the U.S. in the Homestake mine in South Dakota. And gold is found everywhere in the world on every continent. In South Africa, Russia, California, South Dakota, Colorado, Chile, Brazil, Peru, Argentina, Indonesia, China, Australia, and Alaska. Gold in mines is usually not visible to the human eye. Usually the desired rate of 1 to 5 parts per million of gold to ore is mined. 860 kilograms of gold ore, shown here, about 1,800 pounds, yields about 30 grams of gold on the red square, about the size of the tip of your finger. 30 tons of ore is used to get 1 troy ounce of gold, and 1 troy ounce equals 31 grams of gold. How gold is mined? On a small level, on a small scale, it's done in placer mines. It separates gold using gravity and water. There are two other kinds of mines that are mainly used now, that is, on the large scale, open pit mining and underground mining. In open pit mining, it looks like this. It can look like this. And there's one in Alaska that looks like this. In underground mining, they use these kind of machines to take out the gold ore. They are then taken on trucks to be taken to a processing plant. And then there are 2 ways for the ore to be removed and to get the gold out. One is to mix the ore with mercury to form an amalgam. The gold amalgam is heated off to leave pure gold. Also, gold ore can be processed with potassium cyanide, which is a very common way to remove gold from ore. Gold cyanide is then created and treated with zinc, which is an active metal and replaces the gold in the compound, and sulfuric acid is used to get rid of the zinc. However, there is a problem with this. There's an environmental hazard. The release of mercury, potassium cyanide, and sulfuric acid in streams is discharged to nearby waterways, causing ecological damage. Other heavy elements leached out include cadmium, lead, zinc, copper, arsenic, selenium, and mercury. 80% of the over 3,000 tons of gold mined every year uses gold cyanide to leach out gold in the rocks that hold it. This has had devastating impacts to some of the streams and freshwater lakes of China, as well as the Amazon River Basin. And this is how they take care of that gold ore when it's processed. The gold ore is liberated, extracted into a solution, purified, and then recovered into gold bullion. This is the demand for gold throughout the world, generally 55% jewelry, industrial use 10%, and private investments plus bank and government investments of 35%. In the United States, excluding bullion, is mainly divided into jewelry, electronics, and coins and its use. Its other uses of gold are used in medicine. A naturally occurring isotope, Au-198, can be injected directly into a tumor, shown below, where its radiation destroys tumor cells. It's also, shown below, chemically liquefied and injected into rheumatoid arthritis patients as gold sodium thiophosphate. Thin gold wires are used in computer chips to create printed circuit boards and to make electrical connectors. More gold is recoverable from 1 ton of PCs than 17 tons of ore. And this is how they take that gold out of it. That is, you can do this yourself if you wish. Take a printed circuit board, put it in nitric acid, and everything dissolves but the gold, of which you can keep. And gold is used in electroplating, on watches and artificial limbs. It's also reflective and used in space on the visors of astronauts' helmets and to coat the mirrors of the James Webb Telescope that will go up next year that is sensitive to infrared light. Gold can be used in fillings in teeth and caps on teeth. It can be used in facials, and it is edible. It can be put on gourmet foods to be eaten, and can be ground up and sprinkled and put in alcoholic beverages. Carat percentage drops as other alloys are added to gold. 24 karat gold is pure gold. It equals 99.95% gold and is never used in jewelry. It's too malleable. 22 karat gold is 91% pure gold, and 18 karat gold is 75% gold. 18 karat to 9 karat gold with alloys in it are used in jewelry to make it more durable. The silver gold alloy called electrum, that's what it's called, and white gold is 75% or 18 karat gold mixed with 25% platinum or silver and has a faded color. Yellow gold uses alloys of copper, zinc, and nickel. Now 14 karat gold is 58% gold, and 12 karat gold is exactly half gold and other alloys. And 10 karat gold is 41% gold. Most of us in this room, as shown on the brown chart here, have 14 karat to 18 karat gold with the percentage mentions. Fort Knox has over 36,000 bars of gold bullion. Each bar is 400 troy ounces. They have 147 million troy ounces worth over $130 billion. Now 1 billion bullion bar weighs about 28 pounds and costs about $800,000. And this is how much the United States has in its reserves, over 8,000 tons, more than any other country, and is stored in one of 4 locations: Fort Knox, West Point, Denver, and New York facilities. In this basement in Manhattan, there are 6,000 tons of gold, and it's also held for world organizations like the International Monetary Fund. And to make your own gold ring, first buy a ring mold that is made of rubber or wax. Secondly, gather up scraps of gold from jewelry. Third, place the gold in a ceramic crucible, and then heat it with a butane or acetylene torch. And lastly, pour gold into the mold and let cool. Gold is found in quartz and in large nuggets. The largest nugget ever found, shown here, was 630 pounds, found 150 years ago in Australia, was worth in today's money $25 million. And the price of gold over the last 30 years has tripled. It used to hover around $450 an ounce. Now it's about $1,300 an ounce. And the lust for gold is led to greed. These are rings taken from Holocaust victims in the late 30s and early 40s in Eastern Europe. Each ring represents a human life. This gold helps supply a new Nazi war. All the gold in the world is a building compared to the Statue of Liberty. The bottom level is for jewelry, about 84,000 tons. The second level is going up is for private investments, about 30 tons. The third level going up is about the same, about 30 tons for what the government uses for gold bullion, and the top level is for other uses. We still revere gold on ceremonial king's crowns, halos around religious objects and icons, and those ubiquitous gold stars usually given to 4th graders. However, now they're mostly given to villages' real estate agents. There's more real estate agents here than there are residents. And Psychologically, yellow or the gold color was considered safe, positive, edible, and associated with the sun, thereby making it more appealing in our minds. For tens of thousands of years, our ancestors worshipped the golden yellow sun, and golden diamonds are associated with love because of their ever-enduring qualities. Yellow or the gold color is often associated with good-tasting foods like corn, squash, butter, and bananas that are easy to digest and easy to chew. Adjectives abound such as baked until golden brown and golden delicious. Yellow and the gold color are also used in advertising fast food restaurants, which stimulates our brain into thinking we are hungry. Why? You can have a gold-plated bicycle, a gold-plated car, and you can even have a gold-plated toilet. However, be careful of the gold-plated toilet paper because it could be a real big pain in the diamonds, is our next subject. The word diamond comes from the Greek word adamus, or untamed or indivisible. And today we'll be discussing about diamonds, how they were formed, their atomic structure, how they're mined, their history, and how they're distributed, famous diamonds, the 4 C's of diamonds, how they're cut, graded, and sold, and synthetic diamonds. As shown in the blue writing, diamonds formed tens of millions of years ago under tremendous pressure with temperatures between 1600 and 2300 degrees Fahrenheit at depths 90 to 120 miles below the Earth's surface. In order for a diamond to be created, carbon needs 435,000 pounds per square inch of pressure to form, otherwise graphite is formed. Diamonds are brought closer to the Earth's surface with volcanic activity through kimberlite pipes, which are formed 100 miles below the Earth's surface. Magma below kimberlite pipes pushes up the kimberlite, which contains the diamonds, like an elevator through the mantle and crust. The pipes are cylindrical in shape, and they range in size from 5 to 360 acres when they reach near the surface. Kimberlite, shown below, is like a bluish rock miners look for when they're mining diamonds. And diamonds are found in all parts of the world, on all continents. And as we like to say in geology, every kiss begins with K for kimberlite. And diamonds are 57 times harder than any other substance on Earth. This is because the molecular structure of diamonds is carbon linked together in a lattice structure. Each carbon atom shares electrons with 4 other carbon atoms, forming a tetrahedral unit, which forms a super strong bond. Sometimes the impact of large meteorites produce enough heat and pressure to transform carbon into diamonds. Tens of billions of diamonds exist and are naturally occurring, plus many are octahedral in shape, that is, 2 pyramids on top of each other. And they often look like this, like broken pieces of windshield, and they're yellowish and brownish, and diamonds are often embedded into our culture. And the resulting product is to the right, and they're embedded into our culture with this particular song, which is, it's okay, we'll drop it. Thank you. Excuse the MacGyver type ideas that I'm using here. And, okay, now we can get rid of the noise. Okay, diamonds are found about 16 yards down, and in open pit mining, raw rock is transported to special plants where kimberlite ore is processed and rough diamonds are extracted. This one in Botswana they take out 8 million tons of ore per year from this, and they get a couple thousand pounds of diamonds. The same is true with this one in South Africa. And here's one in northwest Australia. It's called the Argyle Mine. And we'll be following this mine throughout the course of the show. This produces chocolate diamonds. And diamonds can also be found in alluvial deposits in riverbeds and coastal and undersea locations. In alluvial mining, water from riverbanks is diverted, and bulldozers cut riverbanks, and that ore is sent to a screening plant. And diamonds can also be moved by glacial activity and glaciers, and geological activity, And water can move diamonds hundreds of miles. That's why workers pan for gold in rivers and for diamonds. There actually is a 1 pound to 1 million pound ratio, a 1 pound to 1 million pound ratio of diamond to host rock. 80% of all mined diamonds are unusable as gemstones and thus used for industry. So out of 1 million pounds of ore, you get 1 pound of diamonds. But out of that 1 pound, just 3 or 4 ounces, which you could fit in the palm of your hand, will be used for gemstones. The other 12 or 13 ounces of diamonds, which you can fit in the palm of both hands, that'll be used for industrial purposes. And we'll be talking about both gemstones and industrial diamonds in a little bit. The largest diamond mine is the Papageia crater in Russia, which is so deep there's a no-fly zone around it for airplanes due to the difference in air pressure around the crater. Who buys most diamonds? The United States does. But these other countries like Belgium, India, United Arab Emirates, China, Hong Kong, Israel, these are all, and well as the United States, these are all diamond trading centers. And the U.S. produces not a lot of diamonds itself, actually. However, at the Crater of Diamonds State Park in Arkansas, you can find and keep your own diamonds. They're very low quality. 70,000 diamonds have been found there in the last couple of decades. And the history of diamonds goes back all the way back to India about 2,000 years ago. Diamonds were found there and cut and polished for royalty. Over the time, just after the Middle Ages, that source dried up. Brazil took over as the next source, and that dried up too. And then came De Beers, which was a diamond company. De Beers was named after a farm in South Africa that was owned by Dutch colonists, and where the first diamonds were found in that continent. And De Beers was founded in 1888 by Cecil Rhodes. In the 20th century, 80% of the rough diamonds passed through De Beers. The Kimberley mine, owned and operated by De Beers in South Africa, around Botswana area, from 1871 to 1914, produced 6,000 pounds of diamonds. And this was the start of the Boer Wars. That is, who would control the mineral assets of Africa? The Dutch colonists there or the English colonists there? And diamonds really are no more rare than many other precious gems. But because the market was controlled by a single entity for decades, De Beers, this created a monopoly. For most of the 20th century, the market was controlled by De Beers, which is a diamond cartel. They stockpiled diamonds mined from many countries around the world and then released a limited number of diamonds for sale each year. That is, De Beers controlled the price by limiting supply. Fewer than 200 people or companies are authorized to buy the rough diamonds that De Beers has. They purchase the diamonds through a subsidiary of De Beers that is called the CSO, or Central Selling Organization, which then controls most of the world's diamonds. Every year, De Beers holds 10 one-week-long sessions at sites where only a few limited manufacturers are invited. These are called site holders. They buy parcel lots of diamonds, shown here, for themselves or other manufacturers. De Beers sells a parcel of rough diamonds to site holders, who in turn sends the diamonds to cutting facilities in India and then to distributors in Antwerp, Belgium, which is a major trading diamond center. And in the past, Hasidic Jews were involved in the distribution of diamonds. They've been replaced now by East Indians. Diamonds are sorted by color, size, and shape. Smaller manufacturers then cut rough diamonds and sell the polished gems to jewelry manufacturers, who sell them to jewelry retailers. Now, Antwerp, Belgium handles 80% of the world's rough diamonds, 50% of all cut diamonds, and 50% of all industrial diamonds. Other trading centers here, shown in the red squares, are Amsterdam, Johannesburg, New York City, Tel Aviv, London, Mumbai, Dubai. There are 28 bourses around the world, or diamond exchanges. Surat, India, cuts and polishes more than 2/3 of the world's diamonds. And that's because it just takes $10 for them to cut a carat there, where in New York City it would cost over $100. Diamonds are also cut in Shenzhen, China. That is, wherever there's a very large labor market that can work with cheap wages, then diamonds are cut there. And we'll be taking a tour of a diamond cutting facility plant in Foshan, China in a little bit. Now, prior to the 1930s, diamond rings were only rarely used as engagement rings. Often those engagement rings were opals, rubies, sapphires, turquoise, that is, more exotic, colorful stones. A A diamond is forever slogan, which we all know, was created by an ad company and convinced each groom to pay 2 months' salary for that ring. And since there's really no aftermarket for a diamond, that is why people hang on to them. This creates more demand for diamonds. That slogan, "Diamond is forever," was voted the ad slogan of the century. That's how significant that was. However, by 2001 to 2009, De Beers' monopoly of the market was reduced to 45%, and 2013 by 38%. This decline was due to an antitrust suit about 18 years ago, which ended the monopoly in 2005, and De Beers made a settlement of $295 million, which is nothing. And as we see in this graph, we see the Argyle plant. I wanted to point this out to you. The Argyle mine goes out of De Beers and goes along with Palladium diamonds, which we'll talk about. De Beers now produces less than a third of the world's supply of diamonds and controls less than half of the world's market. Their brand is the Forever Mark, and they do advertise around the holidays, around Christmas. Actually, diamonds go through a long, tedious routing process from when they are mined out of the ground to when you see them in jewelry stores, hence the high prices. Actually, it costs $134 for a carat. That's what the mine charges for 1 carat to be taken out of the mine. However, by the time that 1 carat is transported, polished, and put on a setting, it will cost 40 times as much. Now, conflict diamonds, or blood diamonds, are diamonds that have been stolen or illegally mined and then sold to raise money for rebel militia or terrorist groups. Most conflict diamonds come from, shown on the map, Angola, DRC, Congo, the Ivory Coast, Liberia, and Sierra Leone. Now 99.8% of all diamonds are conflict-free. A process known as the Kimberley Process Certification Scheme in 2002 was put in place to keep all blood diamonds from entering the market. And actually there was a movie about this called Blood Diamonds. Many of us have seen this. And conflict diamonds in the 1990s perpetuated a decades-long brutal civil war in Sierra Leone. And the Kimberley process made sure each shipment of rough-cut diamonds must be transported in a tamper-resistant container. These diamond lots are tracked at every stage of the chain of trade, and they have a forgery-resistant, conflict-free certificate using a unique serial number and trading number. This is a report of one of those, called a report from the GIA, Gemological Institute of America, where we have a report of the diamond. We have the report number, the date, the exact dimensions to the millimeter, the carat size, and the quality of the diamond, and the symmetry and polish of the diamond. Now, the GIA issues these reports, and there's a place you can go to and take courses in learning about gemology and buying and selling diamonds. Over the past 80 years, they have graduated from this private institution 350,000 people that then go into the diamond business and then educate consumers like us about diamonds. They have extension courses all throughout the world, and this is the gold standard of what it means to be in gemology. If you have a jeweler from the GIA certified, stay with that person for life. Another one of these organizations is called the AGS, or American Gem Society. And these are the countries that produce diamonds, primarily Canada, Russia, China, India, Australia, many parts of South Africa, Brazil, and Venezuela. And these then are the top producers of diamonds. The Russian Federation, in Russia, they handle about 40 million carats of diamonds. And a company called Alrosa then controls these Russian markets, these Russian mines. And they now control about 25% of the diamond market. Botswana is in second place with about 25 million carats. 1/3 of the GDP of Botswana is related to diamonds. And Australia is in 4th place, and that Argyle mine we've been talking about produces thousands of pounds of diamonds. Zimbabwe, which was known as Rhodesia, named after Karl Rose, is also on the list. And there are 7 South African countries in this list. Of these 7, over the past number of generations, they have contributed 4.5 billion carats, or 2 million pounds of diamonds that have been around. These are the countries that have spent the most on exploration of diamonds. Russia leading the way with Alrosa doing this. Second place is Canada, and third place is Angola, of all places. These are some of the most famous diamonds. The Cullinan diamond shown here was the world's largest diamond, discovered in 1905. It was over 3,000 carats, and it was cut into 9 major stones, including the 530-carat Star of Africa, which is embedded in the royal scepter, kept in the Tower of London. And this is the Queen Mum dressed up in her diamond regalia. And the Century Diamond was found in Botswana in the 1980s. It commemorates 100 years of De Beers' existence. It took 3 years to cut 120 facets on this diamond. It's now in private hands. It's 273 carats. And the Orlov was given as a gift to the Empress Catherine the Great of Russia as a political favor from Count Orlov. And it was 189 carats. And we all know about this one, the Hope Diamond. Many of us have seen this in the Smithsonian Institution. This was originally 112 carats, now 45 carats. It's blue because of the boron in the diamond. And diamonds can be a little bit different color. If they're red or pink, that means they have chromium in them, for instance. Now, many of us have seen this in the Smithsonian. And this was sent, by the way, to the Smithsonian in 1938 by regular U.S. mail, which means at one point there was hope for the U.S. Postal System. And now this just made the news 2 months ago in December. They found a 552-carat yellow diamond in northwest Canada. Just wanted to show you the more recent finds. And now there are 4 C's for buying diamonds. And they are clarity, color, carat weight, cut, and we'll talk about cost. The grading system of diamonds was developed in India 2,000 years ago. Remember, rough diamonds have little shine, take effort to sort, to auction off, transport, cut, polish, market, and lastly sell. Now we'll talk about these one at a time. Clarity is the absence of inclusions, surface irregularities, and blemishes. Inclusions are really mineral deposits trapped inside diamonds, like little white dots when they are formed. Inclusions devalue diamonds. Now the GIA has its grading scale for clarity. F for flawless, IF internally flawless, VVS, very, very slightly included, VS, very slightly included SI, and included. Now what that means with a very, very slightly included diamond in a traditional cut, you're going to have very good quality. There's no inclusions in them hardly. However, in an included one, there's a lot of inclusions, and this then stops the light from coming into the diamond and then coming back up to your eye. And inclusions look like this, kind of like a smudge area on the diamond, or little white dots, as I've been saying. Sometimes they're mirrored because of the cut, and they look like this and this. And clarity influences price. At the bottom is an included one. That doesn't have much value. But an IF, an internally flawless one, has a great deal of value because it's so rare. And the GIA also has the color scale. And the colorless ones are D through F, and the diamonds that are going up and down are really different angles of the same diamond in that class. And the near colorless are G through J, the faint are K through M, the very light is N through P or R, and yellow or light is S through Z. And completely colorless or D level is the best, going down to other levels, which are slightly yellowish, which sell for less. Color is evaluated on the absence of it. Colorless diamonds are rare because they are free of flaws. Yellow to brown ones are more common, but the colorless ones receive the highest grade and highest allure. As you can see in the grading scale they have, it's clear the way it goes down in the alphabet, they get more yellow. And that's because there's more nitrogen in the diamond. The more nitrogen they have, the more light yellow they get, and then kind of brownish that they get. And in the past, these yellow and brown diamonds were considered kind of useless and meant for industrial purposes. Now people want them on their rings. They're very common now. They're very popular to have on the rings. So this is where the Argyle mine comes when they produce chocolate diamonds for Levian. And for Levian, there's a grading scale. The more chocolate they are, the more they're worth. because there's a popularity for these colored diamonds. And they are 50% less than regular diamonds. And of course, the color is, the less color there is, the less it's worth. Excuse me, the less color it has, the more it's worth. And the more color it has, the less it's worth. And these are the kind of cuts. Cut unleashes a diamond's light, and the best diamonds have the ability to transmit light, sparkle, and are scintillating. Some cut shapes shown here are round, heart, oval, marquise, pear, azure, emerald, etc. A cut grade is really about how both the facets interact with light. An excellent cut here has even patterns of light and dark areas. Facets influence a diamond's face-up appearance, and brightness refers to light reflected internally and externally. Fire is the scattering of white light into all colors of the rainbow, clearly shown here, and scintillation and sparkle is light and dark areas caused by reflection. And we can see different cuts, the round, which is the most classic, and then maybe a oval shape, and a pear and a pear shape down there. And you can actually cut diamonds by yourself. To cut rough diamonds by hand, you first cleave it on a tetrahedral plane. If you can't cleave it, you saw it with a phosphor bronze blade at 15,000 RPMs. The table is the flat part of the skull in a traditional cut, and the girdle is the outside rim. Then to cut it by hand, it is bruited, or tried to make round, where the diamond is adhered to a small stick or a clamp and put on a fast-turning lathe, which cuts the stone. Then the diamond is polished with an abrasive diamond powder. Now, when cutting, there's a 50% loss with the diamond. The rough diamond is really a delicate process. It needs skills, tools, experience, and scientific knowledge about cleavage planes. A good cut has better optical symmetry. A round, brilliant cut is the most popular and classic cut. The cut is the most important factor if you want a sparkly, brilliant diamond. And as we can see, for an ideal cut, the light goes into the diamond, bounces back, and then comes back up to your eye. That's where you get the fire, the scintillation, and the sparkle. However, in a shallow cut, the light comes into it and bounces away. The same thing with the deep cut. It comes into it and bounces away. And as we can see here, an excellent cut has even patterns of light and dark areas. I'm sorry, I got that wrong. A brilliant cut yields 58 facets and really maximizes fire and brilliance. Cut refers to symmetry, polish, and how light bounces off each angle of its facets. An ideal cut makes diamonds look larger. And we can see how a brilliant cut is shown here, where a less brilliant cut is shown here. And let's find out why the differences in cuts make a difference with diamonds. An excellent cut has these even areas of light and dark areas, and have these reflections that come to us that are actually geometric prisms that are reflected back up to their eye, and are called true hearts. They're elongated triangles, and they come in a geometric fashion. That's what an excellent cut has when you get a diamond. However, a good cut, an inferior cut, has these true hearts that are truncated, irregular, and misshapen. And there's either too much light area accentuated or too much dark area is accentuated. So, if we see a good cut here, it's an inferior one. It doesn't have the true heart shown. It's misshapen. But the reflections that come to your eye with a super ideal cut is the best. And this greatly influences price on how the diamond is cut. And you can get it, when you go to a jeweler, you can use an ideal scope, which is really a microscope at 10 powers, and you can see the diamond yourself, what it looks like. In a poor cut, you can see a lot of areas of white coming through. That means that there's light, that's light not coming to your eyes. But in an excellent cut, there's no white, and you can see the geometric patterns coming to your eye. And with these three diamonds that go east-west on here, they're all 9/10 of a carat, but the one in the center costs the most because of the way it's cut. These other ones are a little bit inferior because they don't have the true hearts accentuated enough or too much. And the same things with these four diamonds here. They're all 1.5 carats, but the one that's cut the best is worth considerably amount of pound of money. And now we're going to take a tour of a diamond cutting facility in Foshan, China. Foshan, China is on the southeast coast of China. And this is a company there that's owned and operated by the Chow Tai Fook Company, which is a major retailing jewelry giant in China. They have $7 billion in sales, and they are located in Hong Kong. And this Fook Company mainly caters to China's middle class, which is now 300 million people. They have 1/3 of all the world's middle class, whereas just 30 years ago there was only 50 million in that middle class. That area has skyrocketed for them. And what this company does is it takes out the middleman with diamonds and processes rough diamonds themselves. And what they do is, first they paint a diamond to scan it. And then when they put it on the computer, they can find it where they can get the cut into it. As you can see, most of the diamond, 40% of it will be taken away in the gray area. And they try to make the best cut. And then they calibrate it and measure it. And then they're put on a screen to map out inclusions. Inclusions are those little deposits that devalue diamonds, they're sold. So they want to find out what the least amount of inclusions are in the rough diamond that they have in order to plan out the cuts. And then cuts are made to avoid inclusions. They're cut on tetrahedral planes, and of course they're not different colors, they're just shown to highlight them. This will be a 16th of a carat of a diamond, this will be a 1/3 of a carat, and this will be a 1/4 of a carat. As you can see, they try to get around the green seaweedy inclusions here, which make the cost of the diamond go down. And then they're taking the machines where they are grueted. That means they are cut to make those different cuts that we've been talking about, like azure, emerald, round, pear. And what that means is they are lined up on crosshairs to be cut with a laser in those machines, and lasers are put them or made them in a certain shape or form. And then they are polished. This company processes thousands of diamonds each week to sell to China's middle class. And 1 carat equals 200 milligrams in weight, and they are divided in points. 50 carat, half of a carat would be 50 points, and a full carat is 100 points. And this is what they look like on your fingers. A half carat, a carat, 2 carats, and then 3 carats right here. So, and with diamonds, size matters. So the 1 carat, shown below, the half carat right here, which is 1/2 carat, will be between about $1,500. But when we go to the 1.0, which is 1 carat, that'll be between $4,000 and $6,000. And the jewelry shop I call it said between $5,000 and $10,000. That is, when you double a carat size, you're going to triple, quadruple, or quintuple the price. And you see by 2 carats, it'll be about 18, or 2.0, be between $18,000 and $22,000. And the general price is between $17,000 and $25,000, and the 3 carat will be more than $50,000. And if you want to know how much a 20 carat ring, this is Frank Sinatra's ring that he used for an engagement ring. It was 20 carats. It sold at auction for $1,700,000. Now, with this, we'll just pay attention to what's in the box here. These are all diamonds. They're the same color, clarity. They're all GIA certified, but they're different sizes. So the 4/10 of a carat, or 40 points, will be under $1,000. However, if you go 1/10 of a carat up to 0.5, which is 5/10 of a carat, or 50 points, the price will go up 50%. When you go up to 70.75 or 3/4 of a carat, the price will double that price to $3,000. By the time you get to 1 carat, the price will be doubled to almost $6,000, and the 2 carat, again, triple that price up to about $20,000. So the carat size is extremely important. And in terms of the trade, let's just say if you have a diamond that's 80 points, it's VVS, very, very slightly included, has H-color level to it, there's a pear cut and an ideal cut, that is what you really would like to have. And the price is shown below. Now, with the diamonds, the cut is included in the price. The princess cut, which is really a square cut, would be the cheapest cut. That's because it's square and easy to make. The cushion cut would be a little bit harder to make. It's really a square with the edges rounded off. But the round cut is the most expensive because it takes the most time and the most accuracy to develop correctly. And here are some tips for buying diamonds. Just go below the 1 carat mark or half carat mark for a 20% drop in price. Put money into cut, not clarity or color. Round diamonds are the shiniest but priciest. And multiple diamonds shown in the upper part of this. But that is very small diamonds on a ring costs a lot less than one single diamond. If you have a ring that has little multiple diamonds on it, maybe 20 or 30 of them, but it has a carat worth of weight to it, that'll be between $500 and $600 in retail. And nowadays, diamonds, though, are sold online. And a lot of young people do this, that is, they go online and they visit the sites called James Allen or Blue Nile. And with this kind of site, you can make your own diamond, make your own way you want it. That is, you pick the color, the clarity, the carat weight, and they have a video of each diamond that is shown, different angles of it, and then you pick the setting and you put together your diamond like a snowman. And they charge 18% more than a regular jewelry store would sell for. Most jewelry stores sell it between 30 and 60% as a markup. With these online retailers, 18%. You have a 30-day money-back guarantee with these online retailers, but you might have to send it back. You might have to send it to anywhere in the world to send it back somewhere. And with that diamond, you should also get a certificate from the GIA, which certifies how the diamond was processed and taken care of during its course. And no one really wants to buy your used diamonds. You're only going to get 6 cents on 0.6% on it, 60 cents for every dollar on a diamond in a jewelry store, and about 50 cents on every dollar if you go to a pawn shop. Never buy your diamonds from a pawn shop because you don't know what you're getting. And most diamonds are used for industry and for practical purposes and applications, like in the medical field, in flat screen TVs, and in computer components, and as lubricant additives. From the 1950s to 2015, 5 billion carats were used for industrial purposes. Industrial diamonds are used in computer chip production, manufacturing, machinery manufacturing, mining for minerals and natural gas, plus oil on their drill bits, and used in stone cutting and cutting finishing tools. They have high thermal conductivity and are used in high-tech applications, and they're used for cutting, sanding, drilling, and polishing. As we can see on this diamond saw blade, many diamonds here are the yellow and brown kind shown up here that are used for industrial purposes because no one in the past wanted them on their fingers. Industrial drill bits for mining and oil rigs are covered with highly flawed diamonds called bort. Bort, which is really crystallized diamonds, is crushed to create abrasive grit for grinding wheels and cutting tools. Gee, I thought bort was the name of a Russian villain in a James Bond movie. And about synthetic diamonds, I know you want to know about these. Synthetic diamonds can be made by taking graphite and exposing them to high temperature and pressure to create colorless diamonds and colorful diamonds, which are close lookalikes to natural stones. Actually, now 90% of all synthetic diamonds are manufactured in China, and 100 tons of synthetic diamonds are produced every year to make cutting tools and abrasive industrial diamonds. And how they're made is they are put in these high-pressure, high-tech presses. As graphite is put in these machines. And they're exposed to temperatures of 2,500 degrees, atmospheres between 50,000 to 70,000 atmospheres. That is between 700,000 to 1 million pounds per square inch of pressure, and they're baked for a couple hours. These machines do what nature does in a few hours, and that's how they make synthetic ones. And you can actually make, with these machines, colored diamonds by taking diamonds of more than half of a carat, irradiating them, and then putting them in these machines to make colorful diamonds. But you need a certificate from the factory saying this was done, and shown to the other side is how they're done in the machine. Now, I know what you're thinking. How do you tell the difference between a regular diamond and a synthetic diamond? I thought you'd never ask. Okay, the first thing to do is to have these kitchen tests. is first you exhale on them at the top here to see if they fog up. If the stone fogs up, that means it retains heat, and it's not a diamond, it's a synthetic diamond. And a real diamond will not fog up. You can do the same test with your spouse to see if he or she is real by just exhaling them. And the same thing with and about the setting on the diamond. Most synthetic diamonds do not have regular gold in their settings, and they have a little underneath the diamond. They have little letters called CV, which is cubic zirconium. Then you know it's not real. Also, if you use a jeweler's magnifying glass, you can see the inclusions in the diamonds, the little white dots, whereas synthetic ones are flawless. And you cannot read anything at all through a diamond. And no one would do this, would take a diamond off the setting if you did. You'd have World War III with your spouse. However, diamonds can float in water. Synthetic ones definitely do not float in water. And when heating up the stone, and then for 30 seconds to drop it in water, a synthetic diamond will break apart, a real diamond will not. And how they be tested in jewelry stores, they use this little device, it takes about 30 seconds to see if it retains heat. Of course, diamonds do not retain heat. And cubic zirconium weighs twice as much as a regular diamond. Diamonds fluoresce blue, and they cannot X-ray. That's why, of course, they take them on airplanes. They have movies about this kind of thing. And jewelry sales for diamonds have increased tremendously. They're now at about $100 billion for worldwide sales. And diamonds do rot. Lastly, psychologically, diamonds appeal to us because when they are cut and polished, they are sparkly, shiny, and are small. We as a species are addicted to bright, colorful things that reflect light that you can hold in your hand. And I'll prove it to you right now. That's what we're addicted to. Little things that you can hold in your hands, like your iPhones, etc. And this is because our brain is evolutionarily hardwired for visual stimulation. Visual acuity helps our species survive. All the other senses we have of taste, touch, smell, and hearing are mediocre compared to the brain power needed for seeing. It's a guarantee that you will become a billionaire if you develop a product that is useful, can be handheld and shiny bright, like laptops, TVs, or laptop computers or iPhones. And to quote the most intellectual farce or force of our generation, Dolly Parton, yes, it's really hard to be a diamond in a rhinestone world. And it's time for this rhinestone cowboy say, that is the end of my show. Thank you very much.